Alrighty, well I'm back and you're on a tripod. So we're gonna make this work here. I've got to assemble this still. So what I got is a little trans-assembly gel to help me with this, to keep this pin in place. I truly hope this is in frame because if not, it's all for nothing. This gear is gonna go on this shaft and it's gonna engage that pin like it just has. And this one is gonna set in here. Probably put a little lube on it. And has to engage the driven gear. And that is your positive displacement vane type pump or gear pump or gerotor pump or whatever they designate them as. I know there's all different types of hydraulic pumps and I deal with them in automotive application. Like there's a couple transmissions right here. Both have two different types of pumps that operate them, but this isn't too much different, just in a much smaller scale. So I got a couple of alignment pins here, but you can see I got the gears in place. Now this spacer here is pretty much kind of sets the volume or the thickness of this pump, which is directly related to the amount of volume that it can produce. So get that down there all the way. There we go. Make sure it turns. Got to get it into place first. There we go. For some reason it's riding high. You got to figure out why. A little lube, make everyone happy. Get this back in position, there we go. Line up the gears. Sometimes it can be a pain in the butt. There we go. Now we're lined up. The gears themselves are slightly below this plate. Ideally, they want to be about 1/1000, so you can feel this with your fingernail if you want to just run it over. I think 1500 is about the average for most of the hydraulic pumps I find in transmissions. But I don't know if you can see this, but this is what drew my attention to what the failure was. See how one pin is higher than the other? I just pushed it back up with my finger. This height is determined by how this is engaged with it and how it fits on the pump. And like I said, what I saw was this was well below, I don't know if you can see that, it was sitting something like this. So the driven shaft was just spinning, not turning the gears, creating any hydraulic pressure. So we got this back together, and this here's our pickup tube. You can see there's alignment holes here that fall onto these dowel pins. I'm going to push this on, make sure it's all together. And put my bolts in. Now, the bolts that came out of it, there's 4 and 4. The 4 without the washers mount the pump to the body assembly, or the body itself with the ports in it. The ones with the washers assemble the pump. Now, just for purposes of measuring, I'm going to put this back together because I'm going to have to put it together and then get a measurement on it to see how much I have to space it up to keep that, hold on tightly, to keep that pin from falling out again, or the shaft from falling down far enough to disengage that pin. And if you're asking if there's a torque spec for these, I'm sure there is, because I have not yet found a bolt that doesn't have a torque spec. So use a little common sense when tightening these. Get them tight, don't break them. How much is that in terms of torque? I don't know. Use your best judgment. So now looking at this drive flange right there. It's all in. This turns freely. Good to go. I'm going to mount this on the body. What I am surprised with is that there's no O-ring here, which I figured there would be, but apparently there is not. Apparently the machining surface is adequate enough. No, that's not true. There was an O-ring here. I will have to find it. But for now, we're just measuring and setting our depth. Let me get this over here in the frame. Okay, what I was talking about, there is an O-ring that sits here. I'm surprised that there wasn't a large one in here, be that as it may. Not that it's the end of the world, it doesn't matter. But anyways, the pump is mounted with the pickup down facing this tube as well. And as you can see, there's these two alignment pins right here. These come out, they will fall out, so just be aware of that. And this sets in here like so. And these guys go into place here. Be careful. Yours may not turn that easily and you may break it. If you break it, it's on you. So anyways, at this point, you can see there's a seal here, and this is where the shaft goes in. Just a point of fact, don't try to put this shaft in this direction because you catch the lip seal and you can tear it. So I'm gonna put a little lube in this and put my shaft in. Be careful not to cut the lip seal. There are 2 needle bearings in there as well that support this shaft. There we go. You'll know it's all the way in. I want to pull this out and look at something. See if there's any kind of wear mark or what we refer to as a witness mark on this shaft. Yeah, you can. I don't know if you can see this. I'll try to get this in. But there's a polish mark right there where my fingernail is. That's where the lip of the seal was riding. And the lip of that seal is down here at the bottom. It is not up here, it's down here. So when I get this into place, it gives me an idea as to how far it is sitting down in there. And it doesn't look to be too far at all. But this may be where my problem is in terms of the depth of this pin and coinciding with the depth of this pin and how it disengaged. I don't see anything unusual about that, so, or nothing obvious, I should say. There was no nylon bushing or anything in there. So what I'm going to do is I'm going to take this apart and I'm going to take a look at this point where these pins come up through here, just to see if there is if there's something that has worn out in this pump that allowed the pin to move and disengage the gear and turn on and falls apart. So in here there's a couple of ports. I don't know where or if this is the actual cause of the concern, if it's in this body that's worn. I don't think it is. I don't see anything. And in terms of the pins, this head height here is equal to this head height less the drive cog. So everything appears to be okay, and you can see how these are turning. So I don't think the issue is going to be in this body. And I have no real way of adjusting that height at all. And this guy here just loves to move. So let's put a little sticky grease on it. The beauty of this trans-assembly gel is it's pretty sticky stuff. It's used often to hold thrust washers into place. So during assembly, things don't fall apart on you, like this is having a tendency to do for me. put this together, bolt it back up. Flip it over, put the shaft back into place. Go ahead and engage it. And then from here, the motor goes on. You can see there's a drive piece on here that simply engages, this drive piece. So go ahead, try to rotate this to get where you need to be. Now you may have to pull the bolts back in the motor just so you can have an ability to engage the drive unit. Then turn the motor into the position it needs to be, put the bolts back into place. And tighten it up. Okay, so now this is back together. And I don't know why I bothered to assemble this, probably just to get a better look at how to set that depth. But you'll see here, once I get this apart again, you'll see how this is got a little too much room for movement in it, which I don't like. Kind of difficult with the motor in place to get you into a proper position to see what I'm talking about. But get these out. There we go. Now, in this case, you can see that this one, maybe you can, is pretty much equal. But now look, I push it down. You can see, maybe you can, maybe you can't. Let me get into position. See how much this one is sitting lower than this one? And that's where the issue came in. Because the way the drive cog was on it, it was disengaging. And I can see right now, and you probably can't see it on the camera, it is right on the edge of disengagement already. So for whatever reason, this shaft is sitting low. So I gotta correct that. When I find a solution, I'll show you. But this is the amount of movement that is in there that it probably shouldn't have. And it doesn't have anything to do with the motor itself, because there is no movement in the motor versus the thrust bearing that's in the bottom of this motor. The shaft in here is stable. It doesn't move. So I got to figure out why. And maybe this is just a worn body here. Remember we talked about a bushing that was in here, and this pin was riding the top edge of that bushing. Maybe that's no mistake. Maybe that was a design for this, where that pin would actually ride the top of that bushing and set that depth. If that is the case, I may be able to push that bushing down 1 or 2 millimeters, and by push it down, I mean in this direction, so that pin would ride on that bushing once again. But I don't like that, because that pin is a high carbon steel pin, and it's just gonna work right around that. Now, ideally, this is supposed to float, so there should be no downward pressure on it, but it's a hydraulic pump. It's building pressure. Hydraulic pressure is gonna push this pin in one direction or the other. And based on these ports in here, I got a pretty good feeling it's gonna push it in the wrong direction. Well, actually, those ports aren't ports at all. They're bleed holes, I see now, to allow that to bleed off pressure so it doesn't do just that. So, all right, I got to figure out what the heck's going on with this thing and why it's doing what it's doing. Once I have a correction for it, I'll add it to the video. But for now, that's what's going on with this. And I will find a solution and I will get it corrected. Until then, see you next time.